Electrolysis Part 2, Applications of Electrolysis. Unit C2, Section 7. You need to know about electroplating, the electrolysis of brine, and the extraction of aluminium. Electroplating is using electrolysis to cover an object in a layer of metal. The object must be able to conduct electricity so that the electrolysis can happen, and only the parts of the object dipped into the solution will be covered. In this case, the top third of the spoon wouldn't be covered in copper. Metal ions are positive and so are attracted to the negative electrode. The object to be plated is made the negative electrode. The metal being used to cover the object is made the positive electrode, and the electrolyte is a solution of a compound of the metal. It doesn't matter which compound, but all nitrates are soluble in water, so the metal nitrate, copper nitrate here, is a good one to use. At the negative electrode, metal ions gain electrons to form a layer of metal. This is called reduction. If you're doing the higher tier, you'll need to be able to write the half equation for the reaction. At the positive electrode, the metal loses electrons to form metal ions, so overall, for every metal ion deposited on the negative electrode, one atom forms an ion and dissolves at the positive electrode. The solution doesn't get used up. Things are electroplated to make them look more expensive or to protect them. Steel cutlery can be electroplated with silver to protect it from rusting and to make it look like silver cutlery. Electrolysis of brine, that's sodium chloride solution, is a really important industrial process. Brine contains Na+ and Cl- ions from the sodium chloride and H+ and OH- ions from the water. At the negative electrode, hydrogen is made. Chlorine's made at the positive electrode. The solution left behind contains the Na+ ions and OH- ions, and so it's sodium hydroxide solution that is left behind. All of these three products, hydrogen, chlorine, sodium hydroxide, are really important in industry. You should be able to explain why hydrogen and not sodium is made at the negative electrode. Both Na+ and H+ ions are attracted to the negative electrode because they have a positive charge. Looking at the reactivity series on your datasheet, you can see that hydrogen, a third the way up from the bottom, is a much less reactive element than sodium, which is at the top of this list. This means that the element hydrogen will be made from the H+ ions. So the H+ ions gain electrons to form hydrogen gas. You need to know that chlorine's used to make bleach and plastics. Please don't say that chlorine is used as a plastic, it really isn't. And you also need to know that sodium hydroxide is used to make soap. Again, don't say it's used as soap. Sodium hydroxide would dissolve your skin if you washed with it. This is a way of removing dirt, but it's not recommended. In Unit C1, you should know that hydrogen is used to harden vegetable oils, and if you do Unit C3, you should know that it's used to make ammonia. Aluminium, as you may remember from Unit C1, is extracted by electrolysis. Aluminium oxide is mixed with cryolite to lower its melting point. The mixture is melted and electricity is passed through it. You do need to know why cryolite is added to the aluminium ore. The process would need a much higher temperature to melt the ore without it, and so would be much more expensive because you'd have to use much more energy. Aluminium ions are attracted to the negative electrode, where they gain electrons. They're reduced to form aluminium metal. The oxide ions, which are negatively charged, are attracted to the positive electrode, which is made of carbon. Each oxide ion has a 2- charge, so each will lose 2 electrons. Once the oxide ions have lost the 2 electrons, they become oxygen atoms, and these atoms pair up to form oxygen molecules, O2. The oxygen molecules bump into the carbon electrode. The electrolysis takes place at nearly 1,000 degrees Celsius, and at these temperatures the carbon reacts with the oxygen to form carbon dioxide. The positive electrode burns away, and eventually it will need to be replaced. If you were doing the higher tier, you'll have to be able to write half equations for the reactions at the positive and negative electrodes. Just as before, the aluminium ions gain 1 electron for every positive charge they have. The oxide ions lose 1 electron for every negative charge they have. And don't forget that the oxygen formed will then react with the carbon to form carbon dioxide. That's it for electrolysis and for Unit C2. The next stop will be answers to the practice questions. You should pause the video and have a go at the questions in the pack you downloaded. Do watch the different sections again to help you answer the questions if you get stuck. When you are ready, go on to the answers.